All right, so we're going to take a look at section 9.1, which has nothing to do with complex numbers. Okay, so we were doing that in the last section. No complex numbers at all. So up until now, every graph that we've looked at has pretty much been functions. Okay, meaning if you draw a vertical line, it passes it. Well, there are some graphs. First two are a little more complicated than we're going to get into. But the third one might be something we look at. None of these graphs pass the vertical line test. None of them are functions. You can't draw any of those graphs with the way this calculator is set up right now, because this calculator is in a certain mode. Specifically, it's in the mode that we've called function. And we've never changed that mode. We've kept it in function all year. Well, there's 4 other modes. Parametric and polar are the 2 that we look at. And the nice thing about polar is it's very much connected to what you just learned in the last section. If you can write a complex number in trig form, then you can do polar, no problem, because that's basically what it is. But parametric's a little bit different. So we'll talk about what that is right now. Okay. Let me change the mode to parametric and just go to y equals and show you the difference. Okay, so let's take that, put that there, and let's put it back in function mode and then look at that. So what do you notice, for example, if you look at just graphing something in blue? What do you notice is different between graphing an equation in blue using the left, which is function, and using the right, which is parametric? Yeah?
It has both x and y.
Yeah, there's 2 equations. So when you graph something parametrically, the big difference is you have one formula that generates the x value of the coordinate, and then you have a different formula that generates the y value of the coordinate. That's the difference. Okay, parametric breaks it down like that. Where function doesn't. Function, you have one formula, and that one formula does everything. Okay? Because you have one formula in this mode, you can't necessarily draw as fancy of a graph. If you break it up into 2 equations, then we can start drawing things that are much, much fancier. All right, so let's call those 2 functions that we would type in. Okay, they call them x1 and y1, or x2 and y2. That's what they call them. I'm just going to call them f and g. Best to say. So let's let those 2 functions be f and g. And those functions are going to be defined on what's called an interval. Okay, so I'm going to have to talk a little bit more about what an interval is. But the other thing is, when you graph something, and I give you 2 functions, normally you say, well, I can plug in anything I want for t, as long as I don't divide by 0, and as long as I don't take the square root of a negative. With parametric, that's not true. You cannot plug in anything you want, even if it doesn't result in a problem like dividing by 0. You can only plug in numbers for t that they allow you to plug in for t. Right? So in this particular problem, the interval that you are allowed to plug in here and here is any number that you want between 0 and 1. Mathematically, could you plug in 5 here and do 2 minus 5? Sure. But they don't want you to plug in 5. If they only want you to plug in numbers on the interval from 0 to 1. So that interval will be given to you anytime we do a parametric problem. Okay, so that's what I mean by interval. So if you take all the different numbers in this interval, like let's say we're going from 0 to 1. Obviously you can't take all of them. But if you take enough of them, maybe take 10 points or so, and you take those numbers and you plug in to the two formulas that you're given, you'll be able to get a sketch of your graph. Okay, when we draw things parametrically, our book refers to pretty much everything as a curve, even if it's not curved. The book calls any parametric graph a parametric curve, which is kind of weird. Even if it's a straight line, they still call it a parametric curve. And that's probably because when you draw things parametrically, most of them are curved. You can draw straight lines parametrically. But if all you really need to do is draw straight lines, we already have a good system for doing that. You just use y equals mx plus b. That works fine. So the two equations that you have to be given when you're going to draw something parametrically, they are called parametric equations. And you have to be given two of them. If I ask you to draw something parametrically and I only give you one, you can't. It's kind of like if I said to you to graph this point, 3 comma question mark. You can't. You don't know the other number. Okay. You got to know both to be able to do it. The letter that we generally use when we're doing things parametrically for the variable is t. And you'll notice that on the calculator. The button that we always press that gives us an x, it has 4 letters on it. Well, when we've pressed it, it's always given us an x. If you put your calculator in parametric mode and you press it, you are not going to get an x. You're going to get a t. So t is kind of the standard letter that they use for the variable. And they don't really call it a variable. They call it a parameter. It means the same thing. Okay, so the letter t in a parametric equation, that is like your variable, but the book will refer to it as a parameter. A parameter is just something that can change, like a variable. So most of the sketching that we're going to do parametrically, if we have to draw our sketch, it would be on the calculator. So that's pretty much the skill for graphing. We won't be doing a lot of graphing by hand, parametrically. So when you draw something parametrically, say I had a curve and it looked like that. That's my parametric graph. I started somewhere and I stopped somewhere. Okay? Parametric curves always have a start point and they have an end point. Even if it's on a shape where you can't see it, like if I go like this, you can't really tell, well, if I draw it perfectly, you can't tell where I start and stopped, but I did start and stop somewhere to draw that picture. That's something that we're going to want to know how to figure out. Okay, so I'm going to give you two equations, and I'm going to say, if I were to draw this, tell me the coordinate I would start at, and tell me the coordinate I would stop at. Now, if you know where something starts, and you know where something stops, does that tell you what the graph is going to look like? No. No. I mean, it tells you where you're starting and stopping, but how are you getting from starting to stopping? Right? Is it just a straight line? That's the simplest way to do it. Or is it something like that? I mean, who knows? So just knowing where something starts and stops doesn't necessarily tell you what it's going to look like. You'd need some more points in the middle to figure that out. So let's say that we have a parameter that goes from a starting value of A and a stopping value of B. the problem we're about to do in a minute, we're going to do a parameter that starts at 0 and stops at 1. But let's just say in general, it starts at A and stops at B. This number, the lower number, is going to control where the graph starts. The higher number is going to control where it stops. So how do you use that number to figure out where it starts and stops? Well, you know the lowest value you can plug in for t in this problem is a 0. If you fill 0 in for t, in right there and right there, it'll give you the coordinate for where the graph starts. If you want to know where the graph stops, you're going to take the higher value and you're going to fill that in for t here, and you'll get the x here, and then you'll get the y, and when you put an x and a y together, you get a coordinate. All right. So you have to take this number and fill it into the formula to figure out where it starts and stops. So there's 4 calculations you have to do. The starting x value, the starting y value, the stopping x value, and the stopping y value. Those are the 4. And that's how you find it. Plug the starting value into your formula for x. Plug the starting value into your formula for y. Stopping value, plug that into your formula for x. Plug the stopping value into your formula for y. And even though just knowing where something starts and stops doesn't tell you what it looks like, that's still good information to know if you're trying to sketch. Where does it start? Where does it stop? That may help you set your window on the calculator. Now, if we know that something, say, starts here, stops here, does that mean that I could just set a window on my calculator like that, and I would see the whole graph? Not necessarily. It could go outside that box. If it was connected with a straight line, then yes, that would be okay. But maybe this graph does this. So if you set your window to put the start and the stop in the corners, you're going to lose part of your graph. But it's still helpful to know. All right, so let's try this one. So here is a pair of equations. They're called, again, parametric equations. The first one is 1 minus 2t, and the second one is 2 minus t. The first formula is how you generate your x values, and the second formula is how you generate your y values. Now, I am limited as to what I can plug in for t. I can only plug in numbers between 0 and 1. They want me to find the start and the stop point for this curve. And maybe it's not even curved. Maybe it's just a straight line segment. That's what they call it. Okay. What number here is going to control where my graph starts? 0. And what number is going to control where it stops? 1. Now, I'm going to say controls the start, controls the stop. The 0 and the 1 are not the start and the stop. You have to plug them in. So if I want to find the x value of where my graph starts, I need to plug in 0 into the x formula. If I want to find the y value where my graph stops, plug in 0 into my y formula. Okay. If I plug 0 into my x formula right there, what will I get?
1.
1. It's going to be 1 minus 2 times 0. That's the x value of where my graph starts. How about if I plug in 0 for t in my y formula?
2.
2. I get 2 minus 0. Okay, so the starting coordinate is 1, comma 2. That's where the graph starts. All right, and when it's done, where will it stop? Okay, so to find where it stops, I'm going to plug in a number into x, and that same number I'm going to plug into y. What number do I plug in to find where it stops? 1. Okay, so plug 1 in for t. You're going to get 1 minus 2 times 1. Well, 2 times 1 is 2. What's 1 minus 2? Negative 1. And if we plug 1 in for t in the y formula, you get 2 minus 1, which is 1. Okay. So this graph is going to stop at an x value of negative 1 and a y value of positive 1. So think about if you draw those points. When you sketch something on the calculator, think of any graph we've done all year. What direction does it draw the graph on the screen? From
Left to right.
It always went from left to right. Okay? Well, you're starting at 1, 2, and you're stopping at negative 1, 1, right there. As you travel from start to stop, what direction are you heading?
Left.
Yeah, you're heading left. So when we draw this, we've never seen the calculator do it, but it's going to draw right to left. That's how it's going to do it, not left to right. Okay, let's try it. Bless you. Okay, so first thing, if you are not in parametric, you want to put your calculator in parametric. Okay, go to window. I'm going to start with a window that includes those 2 points. If the graph curves outside of it, I'm going to have to fix it. But I'm going to go, I'll go like negative, just to have a little extra, let's go negative 2. I'll come back to that in a second. Just leave that on whatever it's on right now. So for x min, let's go negative 2. X max, I'm going to go 3. So I got a little extra. Y max, well, I'm up at 2. I'm going to go to 3. And y min, I need to go down to negative. No, I need to go down to 1. I'm going to go to 0. Okay, so that just sets my window. Negative 2 to 3, and 0 to 3. Now, there's also a spot to type in your interval. This first one was the lowest t value. Right? 0 was the lowest value. We call that minimum. That's t minimum. This number is the highest value you're allowed to plug in. It's the maximum. So there's a spot in the window for that minimum and maximum. So 0 to 1. Okay, t-step, I need to explain what that is after. Just put it on point 1 for now. Okay, so that's everything you should have on your graph. Okay, let's hit graph. It's going to do it pretty quick, so you can watch it. They'll go right to left. Oh, you got to put your equations in or it doesn't draw anything. So x is 1 minus 2t. Remember, to get the t, you just press the button for that we normally did for x. And y is 2 minus t. Now hit graph, and it did go right to left. So that is a simple graph. It's a line segment. That's all it is. And it doesn't keep going. That is the whole graph. It doesn't go on forever in any direction. Okay. Any question on that graph? Now, what's this t-step? Well, when you are graphing something, you have to, parametrically, you have to tell the calculator how many points do you want it to graph. Okay? Let's say you were graphing a circle, and you said to the calculator, I want you to draw a circle, and I want you to use 4 points to do it. Well, if you only use 4 points, are you going to get a good circle? No. Because the way parametric graphing works is it plots a bunch of points and then it just connects them all. That's basically what it does. So if you want to draw let's say you want to get that graph. But you tell the calculator you can use 4 points to do it. The calculator will draw 4 points. 1, 2, 3, 4. And then it will connect those dots. And that's what it would draw. Now, if you tell the calculator you can use 8 points, that's going to be a little bit better picture. 8 points. Still not a circle, but it's going to give me something that's a little better. Gives me kind of like an octagon. So the more points we allow the calculator to use, the better of a sketch we're going to get. That's what this t-step does. So this was 0. T-step tells the calculator, start at the min, go all the way to the max, and the t-step is the increment that it's going to use. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. So it's going to go up from the minimum to the maximum by 0.1. Any question on that? Now what it's going to do is it's going to plug in 0 to both of those formulas and plot the point. Then it's going to plug in 0.1 into both formulas and plot the point. Then it's going to plug in 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. So you're going to end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points from here to here. That's basically what it does. Now, if I change the t-step to be 0.01, now what the calculator is going to do is it's going to start at 0, it's going to go all the way to 1, and it's going to count in increments of 100th. So it's going to take 0, plug it in, 0.01, plug it in, 0.02, plug it in, 0.03, 0.04, all the way till it gets to 1. So it's going to count by a smaller number. It's going to plot a lot more points. What do you think is going to happen when I hit graph if it plots a lot more points?
It's going to take longer.
It's going to take longer. Still didn't take that long. Now, if I go by 0.001, it's going to try to graph what would that be? 1,001 points. It's going to take a while for it to do that. And I'm not really getting a better picture because it's just a straight line segment. I don't need that many points to graph a straight line segment. 10 was plenty. It was more than enough. Where you would need more points is when something curves. Okay, the more points you use to approximate the curve, the better picture you get. But you don't want to use so many points that it's going to draw it that slow either. So generally, if we are drawing between 10 and 100 points, that's usually more than enough. Okay. And we'll do some of that curve in a minute, and you'll see it. All right. Any questions how we got the start and end point of those two graphs, those two equations? Okay. So sometimes what we can do is we can take an equation that is written parametrically and make it not parametric. Change it back to the kind of formula we're used to, okay, like y equals mx plus b, if it was a straight line. Okay, so what I'm going to show you now is how do you take something that's parametric and change it back to the system of graphing we're used to using. It's basically taking two equations and merging them into one. So if you get confused when you see the directions eliminate the parameter, it basically means take two equations and merge them together as one. Let's try that with our first problem. Okay, I'm going to give you a hint at your first step. The first thing you want to do is take the x equation and solve it for t. I usually write it as lowercase. So take the x equation and solve it for t. All right, let's do that. How would you get, what would be your first step to get t by itself in the x equation? Okay, subtract 1 from both sides. And what would be your last step? Divide everything by -2. So that's gone. And I'm going to think of x as having a 1 in front of it. So that's really -1/2. So -1/2x, and a negative divided by a negative turns that into a positive. That's what you get if you solve the first equation for t. Now, anybody have a guess what we're going to do with that?
Plug that in for t in the y equation.
Yep. I'm going to plug that in for t in the y equation, and that's how you merge the two equations back together. So we get y equals 2 minus, and now fill in t, -1/2x plus 1/2. Okay, if we have to distribute out the negative. What's -1/2 x? Half x. And what's a negative times a half? -1/2. All right, so we have 2. Take away a half.
1.5.
So 1.5 or
3 halves.
3 halves, yep. And we have that, and we have, oh, whoops, I just put that in the wrong spot. So yeah, that's 3 halves. I'm going to put that at the end. And then what else do I still have? I still have that 1/2 x. And that's how you convert it back into what we're used to.
So no, minus 3 half? Oh, I know, no mind.
Well, it's, yeah, 2
okay.
take away 1.
Yep, all right.
Half would be 1.5. So if you put plus 1.5, that's okay. All right, so take the x equation, solve for t, and then you substitute it back into y. Okay, let's draw that and see what it looks like. Okay, so there's my equation when I did it parametrically. Now, let's do it as a function, y equals mx plus b. If we did it right, we should get exactly the same picture. So press mode, put it in function. When you change the mode, the window will stay the same. X min, X max, all that gets carried over. So if you're trying to compare two things, you want the windows the same. So it's accurate. All right, type in 0.5x It's just easier for me to use decimals. 0.5x plus 1.5. Hit graph. Okay, let's compare that to what we have right here. That's what we got when we did it as a function. Okay. Are they the exact same graph?
No.
Not quite. What's different?
One's a line and one's a line segment.
Right. You're only supposed to be drawing that section right there. You're not supposed to be drawing the whole thing. So what we have to do is, when you write it as a function, part of the answer is to give me this equation. The other part of this answer is to tell me where x starts and stops. So you need to tell me, start here, stop here. How do we figure out where to start? Well, when we did this problem, does anybody remember what was the parameter from what to what?
0 to 1.
It was from 0 to 1. I don't care about y. When we're describing where something is supposed to be graphed, we always describe domain. We don't describe range. If we fill in 0, that will tell me where I'm supposed to start and where I'm supposed to stop. But we already did that. We did that right here. What was my starting x value?
1, 2.
When we filled in 0, we got 1. What was my stopping x value?
-1.
-1. So this graph was supposed to start at an x value of 1 and stop at -1. That's what I need to be between -1 and 1. Okay, so if you were converting something and you were just writing it on paper, you need both of these pieces of information. The formula to draw and where to draw it, just from -1 to 1. Okay, I'm not as worried about doing that on the calculator, but if you want to make it actually look the same, you would type this in. X is greater than or equal to -1, and x is less than or equal to 1. Less than or equal to 1. If I type that in, that should now look, I think, like the other one. There we go. So now that's as a function, but I adjusted where to start and stop. Now I know it still draws this blue thing down here. I can't do anything about that. That's as good as I can do to replicate what I had in parametric as a function. Okay. Any questions on that one?
Could I see how you went on the calculator?
Yeah, you don't. We're not going to worry too much about that. You just have to type in the condition in parentheses,
All right, thank you.
telling the calculator where to start and where to stop. And no, I don't think you can do it as a conjunction like that on the calculator.
All right,
I don't think it'll work.
thank you.
Yeah. Good. All right, let's try another one where we eliminate the parameter. Okay. When you are eliminating the parameter, what is your first step?
Combine the equation.
So that's the goal.
You solve for x.
Yeah, that's the whole goal. The first step in that goal is to solve the x equation for t. Okay, so if we get t by itself in the top equation, what would t equal? X plus 1. T equals x plus 1. Now, what do we do with the x plus 1?
Plug that into T for the y equation.
Yep, you're going to plug it in for t right there. And your answer is y equals x plus 1 squared. So that is what you need to draw. But Was the original graph limited to being between a starting point and a stopping point?
Yes.
Yes, then this one needs to be too. It needs to start somewhere, and it needs to stop somewhere. I don't care about the y value. If I was asking you for the coordinate of where it started, then yeah, I would care about the y value. But I just need to know for x's, what x's am I allowed to plug into this formula? All right. If I want to know where it starts, what number in this interval is going to help me do that? 0. If I want to know where the x value starts, I'm going to plug 0 into which formula?
The x one.
The x formula. If you plug in 0 for t in the x, what will you get? Negative 1. So this is a parabola that you would draw, starting at negative 1 on the x, and the highest value you could plug in, well, what number in the interval tells me where to stop?
The second.
The second one. And if I want to know where x stops, I would plug 3 in to what formula?
X.
Plug that into the x again. And 3 minus 1 would give me 2. So in other words, I want you to draw this, and these are the only numbers you can plug in. Now, mathematically, could you plug in like 7? Sure, 7 plus 1 is 8, 8 squared is 64. But you've gone beyond the numbers you're allowed to use. It's not that it gives you like an error or anything like that. It's just not part of this problem. Okay, so I'm not going to sketch that one. We're just going to eliminate the parameter. Okay, any question on that one? Okay. So sometimes it is not possible to eliminate the parameter. Okay, that is an option. But if I give you a question and say eliminate the parameter, it will be doable. But I'm just letting you know, not everything can be eliminated. If it could, then you could draw anything parametrically and just use a function. But that's not true. You cannot draw some of these graphs using the kind of mode we were used to using before. They can't be done. Okay, so it is not always possible to convert from parametric to function. But in these last two, it was. All right, let's see if we can figure out the equation of a circle. And here's where you're going to see it's important to graph enough points, because a circle is curved. You don't do enough points, you're not going to get a nice circle. So let's think first how we would describe. Don't even think of a whole circle. Okay? Start out by just thinking of one point on a circle. If you can figure out how to describe where that one point is, then you can describe where every point is. And if you can describe every point, then you describe a circle. To describe this point, you need to explain to me how far to the right you're supposed to go, and then you have to tell me how far up you're supposed to go. Those are the two things you'd have to tell me to describe where that point is. How far right and how far up. To help us figure that out, what shape do you think we could draw?
Triangle.
Yeah, we can make a triangle. What would change in this triangle besides the red and the blue side as this point starts to go around the circle? So pretend like the red, the blue, and the black side, they're all glued to that point right there, and they can stretch as we start to drag this point around. What else would change in the triangle as this point gets dragged besides the red and the blue side?
Oh, the angle.
This, yeah, the angle right here. That angle would change. So depending on what that angle is, that would tell you how far around the circle you've gone. That's kind of what we did when we wrote complex numbers in trig form. We described it as an amount of rotation, and that's exactly what we're going to do here. Normally when we use a letter to describe an angle, we use a Greek letter. Well, in parametric, you always use the letter T. Okay, so just to keep it consistent with the calculator, I'm going to use the letter T to describe the amount of rotation. This side is x, this side is y, and the hypotenuse. Well, the hypotenuse is like my radius in that circle. What would be a formula that would relate this side, and that side?
Cosine.
Yep. Cosine t equals what?
X over R.
X over r. And now I think we did something very similar to this. Solve it for x.
R cosine T.
Yep, r cosine t. You've just described to me how to find the x value of any point on a circle. It's the radius times the cosine of the angle. All right, now, what formula would connect this angle, that side, and that side? Sine. And sine would equal
Y over R.
y over r. And solve that for y. And what do you get?
R sine T equals Y.
R sine t. Those are the parametric equations that you use to describe a circle. The x formula is r cosine t, and the y formula is r sine t. Let's keep that up. And I want to find the equation of a circle with a radius of 2. So all I have to do is take the two formulas that I already have and change the radius to what number? 2. 2 cosine t, 2 sine t. That's how you write the equation of a circle parametrically. Now, let's plug that in, try it, and see if it works. So if you're not in parametric, first go to that. Keep it in degrees for now, that's fine. Okay, put in 2 cosine t and 2 sine t. All right. T is my parameter. It's the thing that's changing in this problem. T represents what?
The angle.
It's the angle. How much does this angle have to change in order to represent every single point?
360.
T has to go through 360 values, right, to get every single point on that circle. So let's start at 0 and stop at 360. Now let's graph a point. If I wanted to point let's do every 4. I only want to get 4 points. I'd have to go by what? And how much is a quarter of 90? How much a quarter of 360? 90. So let's graph this by starting at 0, and then we're going to go by 90s. And let's set our window to go from, we're doing a circle of radius 3. Let's try -4 to 4 and -4 to 4. Now, it's not going to look circular because the screen is not a square. The screen is a rectangle. when I start plotting more points, you'll see it looks more oval. Okay. That's what I get if I plot 4 points. 0, 90, 180, 270, and it does go back to 360. If I want to get a better picture, would I want to make the t-step higher or lower?
Lower.
I want to get lower. Let's plot a point every 45 degrees. Okay, that's better. Now I have an octagon. If I plot a point every 1 degree, now I'm going to get a really good picture. Might take a little while to draw it, but it's plotting every single number. It's plotting a point every 1 degree all the way around the circle. That's kind of overkill. I don't need that much. But that is my circle. Now, let's say I did a point every, I'll keep that at 360. Let's say you do a point every 20 degrees. Okay. Is that going any faster? It should have gone a lot faster.
Yeah, you
Oh, I
can-
changed the wrong number. Yeah, change your t-step to 20. You should go 20 times as fast. That's pretty good. All right, I can still see the edges look a little bit blocky, but overall, that's a pretty good picture. Now, let's say I go by 50s. What happened there? There's a hole at the end, right? And the reason there's a hole is because let's start at 0, and let's see if we can get to 360, counting by 50s, right? You get 50, 100, 150, 200, 250, 300, 350. What's the next one? 400. You can't go that high. So 350 is the last one you were able to get, which is not the end point. So what you try to do, if you can, is try to make your t-step a number so that if you count by that number, you will hit 360. If I count by tens, will I get to 360? Yeah. Okay, like 300, 310, 320, 330, 340, 350, 360. You won't get that little gap. Perfect. If you count by fives, that would work. What if I count by 30s?
That'll work.
Yep, that'll work fine.
Yeah.
Okay, counting by 30s. Yep. Not as good though, because now you're not getting as many points. Okay. What if I count by hundreds? No. I'm going to get 0, 100, 200, 300. Next would be 400. So I'm going to get a pretty big gap that it didn't connect. And that's not enough points. It doesn't even look that good. Okay. So you just have to find kind of a balance between plotting so many points that it's taking forever. If you get into a case where it's starting to take forever, like if you do 0.01, we're going to be here all day. All right? So what I need to do at this point is I need to stop it, right? Because I can't press any other buttons while it's doing that. So the way you can stop it, if you realize you're doing way too many, I mean, it's doing it. It's just going to take a long time. If you press second and then off, the yellow circle will stop spinning, and then I can change it and maybe make it something a lot better. I'd say that's pretty good. You're getting a point every 5 degrees all the way around. Okay. So any question on the formula for the radius of a circle? You want a bigger circle? Well, then make that a bigger number. If you want a smaller circle, make it a smaller number. If you really want to see it look like a circle, press zoom and do square. Zoom square makes everything look the way that it should look. Because the screen's not a square shape, but it fixes the ratio of the width to height, so it looks correct.
How do you do that again?
You press zoom square. Zoom 5. Zoom 5 will basically show things proportional, the way they should be. Okay, so So that's the first part of 9-1. There's a little bit left, but we'll finish that tomorrow. Let's adjust that. So 1 through 5, 7, 9, 11, 12. I am changing it a little bit. Okay, 25 is a circle problem. We just did that. I think that'll be a good one to stop with. There's not really many questions there, like 10 questions. So we'll take a little bit more of a look at that tomorrow, because it can be a little, sometimes it's new on the calculator, so we'll practice it.